Hello and welcome to our talk about how customers migrated from Google Cloud IoT Core to Eclipse Hono. Happy to be here. It's my first time at EclipseCon. So let's, doesn't work, okay. Let's do a quick speaker introduction. My name is Matthias Feurer. I'm working for SOTEC, a hardware and software development company in the west of Stuttgart. And I'm really happy to have here with me Jason Hinch from Ingersoll Rand, one of our customers.
Hi, everyone. Yeah, so I'm at Ingersoll Rand. I'm the senior software engineer and the lead on our firmware development, also the primary coder for our firmware development. I'll touch base with you later once we get to the customer experience.
Thank you. Okay, just quick overview of the session agenda. I will quickly introduce our company, SOTEC, and then we will have a recap about what Google Cloud IoT Core was and why we chose Hono. We will present the contributions from ourselves to Eclipse Hono, and then we will have a look at the two customer cases, GM1 and Ingersoll Rand. So just one thing about SOTEC, we're quite new to the Eclipse community. We joined a year ago to the Eclipse Foundation. We do software and hardware development. So we are a company of around 50 people, west of Stuttgart. We are a Google Cloud partner. We have been Partner of the Year in IoT area 2019. Yeah, and we do mostly build up on Google Cloud techniques and services. And one of those services was Google Cloud IoT Core. It was launched in May 2017 as a private beta and got GA in February 2018. And it was finally shut down this year in August. It was a fully managed IoT platform by Google. And it was Google's global ingest endpoint for IoT devices to GCP. It had a volume-based pricing and two protocol adapters, MQTT and HTTP. And as you can see here on the picture, it then integrated with different services in GCP. Most mentionable, Google Cloud PubSub, managed messaging infrastructure. So, and let's go a bit deeper. So the different components of Cloud IoT Core. This was a device manager with a UI, but also a REST API for registering and configuring devices, and also for configuring credentials. And it had some kind of mini digital twin in it. It was storing a configuration of a device, which could then send bit down to the device, and it was storing a state of the device. Then a protocol bridge with two different adapters, MQTT, HTTP, and you could send device to cloud data, telemetry, and state. And there was another direction, cloud to device, where you could send fire and forget commands, and also configuration data. Configuration data was sent as soon as the device was connected to the system. And then in the heart of the system, where there was a data broker that was forwarding these messages to Google Cloud PubSub. Yeah, Cloud IoT Core is now gone to the IoT graveyard. Like other managed IoT platforms, IBM, SAP, Bosch. So for me, it seems that business models are still challenging, and this applies not only for the ones who operate the platforms, but also for the ones that operate the devices. So they need trust to those operators that the platforms will survive. Obviously they don't. And one of the problems I see is that there is a one-size-fits-all dilemma. So you have to either go with what this operator provides, or you don't. Okay, Eclipse Hono, why? Let me start with this slide. We have heard about sustainability in the keynote today morning. And I think sustainability and with it investment protection is very important in the IoT field. So I have just put together my thoughts on open source and closed source managed platforms in this area. On open source, you get flexibility and innovation. So new technologies are either added by the community or you can yourself add it to the product. So it's a living thing. And with the closed source, we saw also with Google IoT Core, you just have a sink or swim approach. You have to jump into the cold water. You don't know what you get, and it's dependent on the vendor if he adds new features or if not. On open source, you have transparency and control, so you can do security audits with the code. You have an overview of performance. You can customize the code. You also have control over the costs. In a closed source managed platform, we just have a black box. You don't know which code there is run, and the price model can change at any time. So, yeah. And then last point, and maybe the most important, when it comes to sustainability, you have in open source the certainty that the solution will survive as long as there is a community supporting it. And in closed source, the vendor can turn off the solution at any time, as it did. And also we have never seen the source code of it, so it's gone forever. So how did we come to Eclipse and to Eclipse Hono? We have been asked in 2022, mid of it, by Google, when Google decided to shut down IoT Core, to build a replacement for IoT Core. And discussions with Google, we came up with a solution to base this on open source. And we looked at a few alternatives, and one of them was Hono. So Hono was started 2016 with the exact idea of creating open source alternative to the hyperscalers' commercial offerings. It provides a uniform API for interacting with millions of devices connected via arbitrary protocols, as you can see on the bottom. And as there was already an HTTP and MQTT adapter, it was one of the fits for us to replace Google IoT Core. Then a few other pros for Hono. It's actively used by quite some companies. So among them, of course, Bosch as the main contributor. Then KiwiGrid, also one of our customers that we talked when we did the decision, and Loxy. Then it's a living project and community, which is quite important for open source. And with living, I mean it's people who actively work on the code, as you can see here in the commit graph. Then I personally was impressed about the clean and structured code base. So, it has a Kubernetes-based deployment, and programming language Java was nice to have. So, because you need to have skilled resources in the company to contribute to this. And let's have a look at the architecture of Hono, and this looks quite similar to IoT Core. On the left-hand side, you have the ingest layer, you have different protocol adapters. Then there is also a device registry component where you have the device credentials stored. And you have here a command router that is sending commands coming from applications down to the devices. And then here in the messaging layer, you see here a Kafka broker, similar to what Google IoT Core was using with PubSub. So this was another win for Hono, because we thought, and it was like this, that we had to do quite small changes to Hono so that it can be a one-to-one replacement for IoT Core. This brings me to the contributions that we did during the last year. So, yeah, one of the specials of IoT Core was JWT-based private public key authentication that was sent with a connect in the password field of the MQTT client, or in the barrel as a barrel token in the HTTP adapter. And we added this authentication method to Hono. Then the Cloud PubSub integration. So previously Hono was just using Kafka, as I said, and AMQP network. So we added complete Cloud PubSub integration, and you can operate Hono now completely without Kafka. Then we added this mini digital twin config and state to Hono. This was added as in an extras package. Then we have a device communication API, so that you can, via REST APIs, send commands and configuration to device. Then one big contribution is that Hono now has a web UI front end based on Angular. And yeah, last but not least, we also had to think about how to operate Hono in GCP. So we created Terraform scripts to deploy Hono automatically to GCP. Yeah, maybe just highlight two of these items. One is the device communication API that you see here, and it mimics the existing IoT Core API. So yeah, if some of you know that, it's very, very similar, and it's contributed to the Hono Extras project, so it's not inside the core. You can install it, but you don't have to. And then the web front end allows you to manage tenants' devices and credentials, do communication directly from the UI to the device, so you can send commands and configurations. And it shows this digital twin information also in the UI, so you see the device state. And this is also contributed to the Hono Extras project. So this is how it finally looks like, operating Hono in GCP. So on the left hand we have the edge device. Here is just the MQTT client, could also be HTTP client connecting to Hono on the MQTT adapter. And then you have the command router and the device registry. To all of them we contributed changes. As device database, we use here a relational database. So the standard is MongoDB, but we use here Cloud SQL from Google. And then here on the messaging layer, we are using, as I said, Cloud PubSub. And this is the way how messages also get transferred to the customer applications. So from a customer application point of view, there were no changes needed, just maybe changing the topics on Google Cloud PubSub. So they could be, just staying the same. And then here in the Hono Extras panel here, we have the device management UI and the device communication UI. And this is just secured with Google own services. So identity-aware proxy for authentication, and then Google Cloud endpoints as a central API gateway. Okay, now let's come to our customers. So the first one, I'm sorry, but I couldn't convince him to come here, or they had no time to come here. First one is Gem1, a company from Belgium. They do smart telematics solutions for industrial fleets. So they are located in Kortrijk, Belgium, have around 75 connected assets in the cloud. And what they offer is these devices you can see here on the bottom, and those are attached to industrial vehicles like forklifters or mobile platforms. They control some functionality of these industrial vehicles via these devices, but they mostly also gather data from them. So directly from the CAN bus of the devices, but also position data, etc. So these are the four things that they do with this. So track and trace, get GPS data and see where those vehicles are operated. Then track the operational efficiency, meaning they just gather usage statistics of these vehicles. Then security and safety features. So drivers of these vehicles have to first go through a security checklist on these devices before they can unlock the device, the vehicle. And then they have some more service and maintenance functions, like checking the battery, checking if those vehicles need to maybe go to a service, etc. So what have been the challenges for them? They started with a quite limited number of devices that have been previously connected to Cloud IoT Core, and one of the challenges was the cost optimization. So this goes into the direction of operating the platform. So their expectation was that this will not be more expensive than Google Cloud IoT Core. So we had to do a bit of tweaking the standard deployment that you get with Hono. So reducing the node pool resources, customizing some machine types, also reducing or adjusting the pod resources, and optimizing a few JVM parameters. And also some other things like Cloud SQL database downsizing, etc. All of this is also contributed, so you can check these deployments that we created. Then the next thing that they did, they were using not only MQTT for their devices, but also an HTTP connection. So at that point, we knew that we have to do a full implementation of the HTTP adapter as well. So adding the JOT authentication to the bearer token, and also adding this config functionality similar to IoT Core. So we did this by adding a special parameter to the post request for getting for the event message. So this is usually used for sending event data to the cloud, and by adding this special parameter, we tell the communication API that this device is interested in a configuration, and are then sending this configuration down via the command router back to the device in the HTTP response. And then I don't know if it's really so special, but we have never seen it before. So those devices had two parallel connections, and then with parallel I mean parallel at the same time to MQTT and HTTP adapters. Gem1 didn't want to break with this existing firmware that was deployed to the devices, so it was mandatory for them. And to allow this behavior, we needed to make sure that we always send commands to both of the connections. The current behavior of Hono was to send commands just to the last active connections, so either to the HTTP or to the MQTT connection. And that's what we did then. So we added a few changes to the command router logic. As you can see here on the right, this is the sequence diagram of how this worked before. So when an application wants to send a command, Hono determines the correct adapter instance where the device was connected to, and then send the command to this adapter instance. Instead of that, we now had to check multiple adapter instances where the device was connected, cache them in the data grid in Finispan, and then send this down. So currently this is not in the main branch; it's on an own branch from us in our fork. So if there's anybody interested in this functionality, then please reach out to us, and we can think about if we contribute this. Yeah, what was the outcome for Gem 1? Nice quotation from the platform manager. The migration of 3,000 telemetry devices to the new IoT platform was a success. So they didn't have any interruption, they had no cost increase, and firmware changes were mainly limited to adjusting some endpoints and topics. Okay, with this I turn over to Jason.
Hi there. So if you don't know Ingersoll Rand, it's a very large company. It's a conglomerate of multiple things. We do everything from precision sciences up to very large industrial air compressors, and that's actually where our IoT is focused on. So this is kind of like some of the products that we have in the air segment. Certainly we're not monitoring couplers, but we're monitoring most of the types of air compressors that are shown in this slide. This is, of course, straight from our marketing department. And so for us on IoT, like obviously we're coming from Google GCP IoT course, and going ahead of myself. All right, so why are we using IoT in the industrial segment? And our main financial motivation is for our services. We have warranties, of course, but we also have Tech Direct, which is our service plan with our customers. And by using IoT, we can schedule our visits more accurately. We don't have to go to a site and find, oh, you haven't been using your machine. We don't actually need to change the air filter right now, but now we just go to the site when we need to, and that saves us a lot. It costs a lot of money. Some of these sites are in very remote places. Think Midwest US, it's actually like a no man's land out there. And the tech actually has to drive a couple hundred miles to get there. But other than that, we're also looking to improve our products, certainly by reducing downtime, because we can stave off failures, but we could also improve our controller logic. We've noticed on some of our compressors, for better or worse, that some of them are being short run, and we're working on control algorithms that can avoid that in the future. And yeah, we also noticed some controller bugs, but mostly because we've never communicated through the controller this way before. And the other thing that we're using is to sell more stuff. That's what every company wants to do. For our IoT Core replacement, before we were at GCP, we came from another IoT platform, so we've gone through multiple generations that had a logical distinguishment between the devices and the gateways, and they were maintained separately. We carried that over into IoT Core, and for that means we were using the gateway interface, which was a little bit more difficult on GCP IoT Core. They actually had to declare from the device that, hey, I'm reporting for this asset every time it connects, which if you're making a scalable system, so we have different instances communicating through other instances as part of that separate logical gateway and asset, it creates a real challenge. But so we needed that in our next platform, though, to keep it going. And our other main requirements were, yes, we wanted to reuse our firmware. And we want to scale up. We were starting off going into, and when we were doing this Hono transition, we had about 25,000 active machines communicating to our cloud services, multiple cloud services. I would say we went through a merger a couple of years ago. So they weren't all on GCP IoT Core to start with. But the ones I was working on were. And yes, fault tolerance. We were using the cloud configuration, so we wanted our edge devices are stateless, so we want to maintain that too. But also, if that configuration is inaccurate, and let's say you have an asset that isn't actually configured in the cloud, but somehow it ended up in that configuration tab, or it was changed, but the device was offline, we need that device to come back online. And if it's trying to communicate for an asset, particularly with that gateway interface, it would actually knock it offline if you weren't listening for errors. So we want to be able to recover in our new system as well. And to we do need to send commands to devices. This is part of our registration process. It's also part of our general maintenance for edge devices. More on that later. And to be able to detect when a device is connected. This one is of particular interest to our services. They want to know, all right, we may not be getting any faults or warnings from a device, but is it actually reporting those faults or warnings? And if it's not online, then who's to say? And device management API. Sorry, I keep looking at the wrong screen. So we need to be able to configure these things, during our registrations. And as far as the Hono implementation, that will be Matthias.
Yeah, so I put the challenges together in the two groups. One is the scalability. So as Jason said, they started with 25,000. In the end, I think we now have 50,000 devices on the platform. And also Hono is built for operating those number of devices, even to up to a few millions. We had a few challenges on some parts of it. One was the web front end, which was developed from scratch by us. So we had to make sure we can efficiently manage those 50,000 devices. For example, searching through these 50,000 devices efficiently. And then we had this gateway feature, so that there are devices that are not directly connected to the platform, but still we want to operate those devices via some kind of gateways. So we added this to the web front end, basically for Ingersoll Rand, so that devices can be bound, unbound, etc. And then what we saw when we started operating those number of devices, is that we had load spikes. Load spikes twice a day when the devices were reconnecting. And we had to resize a few things. For example, the data grid service, so that it can handle those spikes. And we introduced some POTS auto-scaling using a special metric. Instead of the CPU and RAM, we are now using device count, so that we can just make sure that starting from some number of devices connected to the platform, we start a new pod for the MQTT adapters, that we can handle this load. Yeah, the other group of challenges I would call fault tolerance. Ingersoll Rand uses the error topic. This is a special topic on the MQTT broker or the MQTT adapter, sorry, that is used when some kind of error happens in the platform and the device should be notified. And this is done instead of a disconnect. So usually you would get a disconnect, but you can send an error so that the device is informed. It's similar to what IoT Core was offering, but it needed some tweaks, because in case of an authentication failure, it was not helpful to use the error topic. It was better to disconnect so that the device can authenticate again. So it resulted basically in a dead connection, and we fixed this. Jason, final words?
All right, so after the migration, all our devices were able to reconnect, no problem, and all the data was coming through. We did encounter some scalability issues with the command routing, which is still being worked on. It's just more of some settings that how Hono, some configurables in Hono to be tuned. But otherwise, it's working pretty well. And I will say, in retrospect, having implemented both, the gateway handling was a lot simpler. If you're coming from a new implementation, you don't have to do the binding. You do it in the cloud, but you don't have to do it on the device. So the device doesn't have to declare it every time it connects that this is what it's reporting to, and make sure that you maintain that for anything else that might be connecting through it. Yeah, we didn't have to change that much in the firmware, actually. So we're using the same exact keys that we're using when we're connecting to IoT Core. We didn't even have to have like any response from the device during this update. We didn't have to tell the device, make new keys first or anything. We took all the stuff that was already in GCP and all cloud side, and then sent down the new configuration to the device. And our configuration stayed the same too. So that configuration message that we keep in the cloud is the same as it was before we did the migration. And so again, we just copied it directly over from GCP IoT Core, and it still works. And last but certainly not least, we had the dependability of an open source solution. This came as a shock to us when they shut down IoT Core. So we were already starting the migration on our legacy IR devices, but we had a whole nother set that development was ongoing for GCP IoT Core that just kind of got shut down by thrown aside from all this. So fortunately, we won't have to. Knock on wood, won't have to do that again. And I guess that's it for the migration.
Yeah, and that's it for the presentation. Thank you, and I open it up for questions. Yeah, you probably could also use Ditto. I think the main reason was that we really wanted to have a one-to-one replacement. Yeah, so we wanted to have something really similar to IoT Core. So IoT Core had this feature, and that's why for us the easiest solution was to build this in a Hono Extra package, and store it there. Yeah, instead of. But of course you could. I mean, there are probably use cases where you want to have a full digital twin with all the functionality, and then you would use Ditto. For all the others that are just expecting the same functionality that IoT Core provided, you can use this mini digital twin. Yeah, this is it's just a state field and a configuration payload that is stored there, and that's it. So for most people who expect a complete digital twin, this will not be enough, of course. Yeah. Other questions?
So maybe this is a little bit out of context, but do you have any opinion on how Hono compares to other IoT cores? Like, for example, you say it would be like how?
I haven't looked at the concrete features, to be honest. Yeah, perfect.
Are you using Greengrass or any of those on AWS, or are you using like straight up just certificate-based authentication? So it's a lot simpler. I know that the AWS has added a kind of like a digital twin sort of thing on the device, but you have to use specific libraries to get it all up and going. For Hono, you can use a straight, similar to what you're probably doing right now, a straight MQTT connection, but you can, like this config message, for instance, it's maintained without having to have a whole nother layer on top of it. This is part of Hono, so you can, and it's received as a regular command as far as MQTT routing. And of course, I mean, it's self-managed. That's the biggest difference between that and the AWS IoT Core, so that there is a possibility they could put a breaking change in the future in AWS IoT that will cost you time and money to get it, fixed before that gets put out there, or God forbid it was a mistake on their part. But so they're both scalable.
Thank you. Any other questions? Okay, then thanks a lot.